If you are building on Solana or you ever traded a token, this video is for you. My name is Benjamin, and in today's video we are going to cover Solana accounts, a core concept because all the data on the Solana network is stored into accounts. This is part 5 of the complete beginners to advanced Solana development series, and in this video we are going to cover what Solana accounts are, account addresses including PDAs, what rent exemption is, and what the difference is between program and data accounts. We'll then put everything into practice by creating an account, calculating the rent, get the account's balance, and eventually close the account and reclaim the fee. By the end of this video, you will understand Solana accounts and, more important, how you can reclaim your Solana that is held by the network as rent. And with that said, make sure to follow me on X and let's get started. Alright, so before we jump into the code, let's have a quick look at what Solana accounts actually are. Because all the data on the Solana network is stored into accounts, and you can think of the Solana blockchain as a public database with a single accounts table, where each account has the same basic structure and it can be located using its address. So that's what you see here. We have that address and it's associated to an account, and that address is also unique. And this account has the same basic structure as all the other accounts. Now, the relationship between that account and its address is similar to that of a key value pair relationship, with the key being the address and the value being the account. Now, we also talked about Solana key pairs in a previous video, and the main takeaway there was that these key pairs fall on the ED25519 curve, meaning that they consist of a public key and a associated private key, and the public key becomes the account's address and the private key is used to generate a valid signature for that account. And why do I mention this? Because these account addresses that we're looking at now, most accounts use a ED25519 public key as their address. Now, this doesn't have to be always like that. They can also use a program derived address, and this is a deterministically derived address using a program ID and one or more optional input seeds, meaning that this address does not have a associated private key. And if you doesn't know what that means, I highly suggest that you check out the Solana key pairs video where we covered this more in depth. Now, the main takeaway is that these account addresses can be on curve or off curve. And most of the time, these account addresses, when we share them with each other, they are in the 32-byte unique ID format, as you can see here. Now, more important, keeping these accounts alive on the Solana blockchain incurs a storage cost, which is called rent. So if you want to keep this account here, for example, alive, we will have to pay some kind of rent to the Solana blockchain. And to calculate that rent, we need to consider how much data is within this account, as you can see here. So how many data is stored into that account, that will determine how much rent we have to pay or have into that account to make sure that it can stay on the Solana network. And rent can be reclaimed in full if we, for example, close this account. And although that balance that we need to store into that account is called rent, it's more like a deposit in my opinion, because that full balance can be recovered when we close that account. And that's what we're also going to look at, because every time that we buy a token on the Solana network, a associated token account is created, and an associated token account is a token account that holds the amount of tokens for our wallets. And then that token account, once these tokens are sold, often that token account still stays around and we pay the rent for that. And if we close that token account because we no longer hold that token, we can reclaim that rent. And that's what we're also going to look at. So make sure you watch till the end. So it might be that you have some SOL laying around that you can reclaim. Now, before we look at the actual code, I want to mention that there are two basic categories that these accounts fall into. And first, we have the program accounts, and these contain executable code, meaning when we deploy a program on chain, an account is created to store that executable code in, and this is called a program account. Now, depending on how you deploy your program, the data field might also point to a separate account called a program data account, which then in turn contains the actual program code. Now, for simplicity, you can just consider these program accounts as the program itself. And then on the other hand, we have data accounts, and these data accounts, they do not contain executable code. Instead, they store information. And we have program state accounts, which are used by this program to keep the state. And then we have also system accounts. Now, then there are also sysvar accounts, and they exist with a predefined address, and they provide access to cluster state data. And that's all what you need to remember for now. So there are two main categories of accounts, and it's the program accounts and the data accounts. So what we are going to do next is create an account, get the account's balance, and also close our associated token accounts for tokens that we no longer need, and reclaim some actual SOL. So now that we know what Solana accounts are, let's jump right into it and check out the code. Alright, so this is our code base for today, and as you can see, there are many more topics that we're going to cover within this series, so make sure to subscribe so you don't miss any of the upcoming or previous videos. Now for today, we are going to look at these two files here under Solana accounts, and we will start with the create.ts file. Alright, so first of all, we're going to import once again all the functionality that is needed within our script. And then we are going to create our RPC and RPC subscriptions connection. And we covered this before, but what this RPC connection will do is allow us to request the data and get data back on demand. And the RPC subscriptions connection is our WebSocket connection that we will use to subscribe to by using WebSocket RPC methods and get notifications when certain events happen. We covered this in the earlier videos, so if you want to know more about that, check out the previous videos. We will also once again recreate our primary wallet, and we do that by using the load signer from file function, and this function will look at these private keys stored here under wallet ID. And once again, all the wallets that we use in this series are mentioned in the README. And for today, we're going to use this primary wallet here. And again, that key is also stored here, primary. And that is what we do with that function here, load signers from key. We look at that private key and then we return a key pair signer. And then we can use that in the remainder of our script as wallet. Next, we're going to fetch the latest block hash, and that we can do by using that RPC connection that we created. And that exposes a method to us get latest block hash, which we will use once we're going to create our transaction to provide the latest block hash. Next, we are going to set the space for our new account, and this is just a regular account, so we're going to set that to 0. And then we can calculate the lamp ports that is needed to make sure that this account is rent exempt. Remember, if we want to keep this account alive on the Solana blockchain, we need to deposit some kind of rent into that account, and we can calculate the amount of rent that we need to pay in lamp ports using the space here, 0. And then we can use a method exposed by this RPC connection called get minimum balance for rent exemption, and then we provided the space, and then we get the amount of lamp ports back that is needed to make sure that this account is rent exempt. Now next, we are going to output a console message saying the minimum balance for rent exemption for this amount of space in bytes is, and then we will output the amount of lamp ports. So now we have the amount of lamp ports needed to make sure that this account stays alive, and that we will also provide once we are going to create that account itself. Now first, we are going to create a new account address, and that we can do by using the generate key pair signer function. And this we used before to create a new random key pair. However, we can also use that to create a new account address, and that's what we are doing here. Remember, we covered it briefly earlier. These account addresses, they can be on curve, and that's why we use this function here to create a new account. Now the next thing that we're doing here is use that get create account instruction function to create a new instruction that we will be able to add to our transaction. And what we provide here is the pair, which is our wallet that we recreated here. Remember, we derived that from that private key that we have stored here, and that will be the fee pair. That will also be the account that deposits the amount of rent that is needed into this new account. The new account address is this that we just created here using this function here. So new account, the lamp ports that are needed, we calculated here above. Remember, based on that space, we could calculate the amount of lamp ports that is needed to keep this account alive or make it rent exempt, and then the program address. And this is also imported, as you can see here on top, via the Solana program system. And if you hover it, you can actually see the address. And then the amount of space that this account will consume, and also that we specified here, and we can just reuse that here. So now we have the instruction that we can use to put into our transaction message to create this account. And that's exactly what we do here. And we do that by using pipe, and then we store that into a transaction message. So first of all, we're going to create a new empty transaction from version 0. We specified the wallet signer and who will pay the fee. That is our wallet, once again, that we imported here on top. We will set that latest block hash, what we did here earlier, and then we're going to provide or append better the transaction message instructions. And this is an array of all the instructions that we want to give it. And that is for now the only instruction here, create account instruction. So now that we have the transaction message, what we will do is actually sign it. And we can do that using the function sign transaction message with signers. And we provided the transaction message. And then we have a signed transaction. Now I tried to add that signed transaction straight into the function send and confirm transaction factory. However, I got some TypeScript issues or notifications there thrown back at me. So what I do here is take that signed transaction, I spread it, and then I expand the type here and set the live constraint, and then I provide that latest block hash once again here. And then I have a transaction to send object that I can provide to this function here, send and confirm transaction factory. Now in earlier videos we used a function called send without confirming factory, where we just sent and then we had a WebSocket connection running to actually see once that transaction was confirmed. However, this time we're using a function called send and confirm transaction factory, and then we also have to provide the RPC and RPC subscription stream. Now once we run that, we can take that signed transaction and we can also get the signature from that signed transaction, and then we will also output it here within our console. Now before we run this, you need to make sure that of course your local validator is still running or running again, and you can do that by starting Surfpool, that we will use to start up a local validator locally on our machine. And we can also open our Surfpool Studio to see what's actually going on. So back to our code, if we open PowerShell here now and we type npm run 5 and then we do create, this should create that account for us. And as you can see, we have a new transaction signature, but we can also look in Surfpool Studio and then you'll see that a new account has been created for us. Our primary account has been updated because some SOL has been deducted. As you can see here, the amount of SOL that was needed to create this new account. And you can also see that we put in a certain amount of SOL here to make sure that this new account is rent exempt, and that is paid by our primary account. So now we have that new account, as you can see here, and if we copy that, we can also open it in Explorer. Maybe that's better. You can see that we now have a new account, and the assigned program ID is the actual system program, and also it holds a certain amount of SOL to make sure that this account stays alive on the Solana blockchain. Alright, so back to our code, and real quick, what we just did here now is create a new account using the generate key pair signer function. And this creates an account for us, which is an empty account without any real data into it. Now I wanted to show you a real example from an account that holds data. So soon we are going to create a associated token account, which is an account that holds the amount of tokens from a certain token for a wallet. And that token account eventually we are going to close and try to reclaim the fee that is stored within the account to make sure that it is rent exempt. Now you have to know that these associated token accounts have a program derived address, meaning that the public address is not on Curve and there is no associated private key. Now these addresses, they are generated once we buy that token under the hood, so you don't have to generate that program derived address or that associated token account yourself. However, I wanted to show you real quick how you can do that. So if you want to create a program derived address, you can use the function get program derived address. You provide the program address. In this case, we use the system program address, the same as what we used here before, and we provide some seeds. And our seeds for now is just the word Solana. And then we're going to output that in our console, and we're going to check if the PDA and our new account address are actually off Curve or on Curve. If we go back to our console, we can clear this real quick and run npm run 5 create once again, and then we will get that transaction because we are creating an account. However, here we can also see that the PDA is off Curve because it is true, and the wallet that we created or the account that we created, here the address is not off Curve. So with that said, we're now going to airdrop a token into our wallet. You will see that a associated token account will be created that has a program derived address, and then we are going to try to reclaim that fee within that account by closing that account. So that's what we are going to do now. So the best way to do that, what we can do is actually take our primary wallet, so the primary wallet that we have here in the README, and then we can open Surfpool Studio. So once we are in Surfpool Studio, what we can do is provide our wallet here, and we can airdrop a Ray token into that. And we can say that we want to airdrop 100 Ray tokens into our account. Now, if we do that, you will see that a associated token account is created. And this is the token, this is the Ray token, and we can open both. So if we go to our Explorer, the first thing that we see here is the Raydium token, so that is the address. And the second one that we see here is that token account that we created for our primary wallet. You can see here, our primary wallet is the owner. This is the mint, and this is the address of that token account. So if we look at our wallet and then we go to tokens, you will see that we now have 100 Raydium tokens. And if we click on a detailed overview, you will see that we now have that associated token account here. Now, this associated token account has a program-derived address, meaning that this address is of Curve, and it was created once we airdropped these tokens into that account. And this address is unique to our wallet and the combination of the mint. We will always have this address if we buy Raydium tokens with this wallet, and I can show you what I mean. So if we copy this address here and we go back to our file here, so this is a file that we are going to use to close that account, you can see that I entered this address here earlier, and you can see it's the same exact address because we airdropped Raydium tokens in our primary wallet, and it always will result in that program derived address which we can see here. Alright, so now that we know what token account to close, we can continue. Next, we are going to fetch our latest block hash because we are going to create transactions in order to close the token account. Now, to give you a better idea of the amount of SOL that is within that token account, we are going to get the actual account info, and we can use that RPC connection that we created for that here on top, and then we can use the function get account info. Now, if we open, for example, Postman, we can take this token account, and we can also check out the get account info by using a API call. So if you look at get account info, this is a regular API call towards our RPC endpoint, and if we provide that token account here, you can see that we will get back information. And here we can see the mint, which is the Raydium mint, the owner, which is our primary wallet, and the amount of tokens that is within this token account. And also we can see that there is an amount of lamp ports in this account here. Now we can always add more lamp ports to this account. So if we take that address, for example this token address, and we would go back to the Surfpool Studio, what we can do here now is add SOL into that. So if we do that here now we airdropped SOL into this account, so we can do that. There is no issue with that. And if we click on send, you will see that the lamp ports here just increased. And I wanted to make this point because this account can also hold lamp ports even if it is a associated token account. Now, these lamp ports include, of course, the lamp ports that we just airdropped into that wallet or into that account, but it also had the amount of lamp ports in there to make sure that this account is rent exempt and that it can live on the Solana blockchain. Now, why did I airdrop more Solana into this wallet? Because once we are going to close it, I want to show you that all the amount of Solana, including the airdropped Solana, will be returned back to our original wallet. So that's what we are going to do now. So if you are going back to our code, this is one example of course, getting that information. Now, if we don't know the actual token account address, what we can always do is get the token accounts by owner. And here we are going to provide our wallet address, which is our primary wallet. And we are going to fetch all the token accounts that are for the token program that we specify here. So if we are looking at SPL token 2022 program, of course, we have to add that address here. But we now know that this Raydium token that we just airdropped has the regular token program as address. What we can do here now, I can also show you how this looks in a API call. So it's called get token accounts by owner. And if we select our primary wallet here, if we go back to Postman and we use the function get token accounts by owner, and we provide our wallet here and of course the program ID, and if we click on send, we will also get back that same information. So as you can see here, the amount of lamp ports, again the mint, the owner, and the amount of tokens that is within this wallet. Now this time the value is a array. So if we airdrop different tokens into this wallet, more associated token accounts will be created, and then we will have more entries in here. Now for now we only have the Raydium token in there, and that's the next step that we're going to do here. We are going to look within this array that we received here, these token accounts, remember, because there might be more token accounts for this wallet. We are going to see if there is a token account with that mint address that we specified here on top, and the mint address in this case is the mint address of the Ray token. To double check, we're also going to to output in our console that the token account that we specified here on top is the same as the one that we found by getting all the token accounts for this owner, and that we can do by just comparing the two. So we have token account to close, that's what we specified here on top, and then we have the received token address, and this comes from the received token accounts, that second call that we did here. And of course, these two should be the same, and then we exactly know what token account we are going to close. Now, this is of course optional. You can always specify the token account directly here on top, or you can search for a certain token account by querying all the token accounts for a certain owner. But I wanted to show you two examples so you know how to get these addresses. Next, once we have that received token address, we are going to pull out the amount and the decimals. So if we go back to Postman, that is what we are going to pull out, the amount and the decimals, so that we exactly know how many tokens we have. So the amount, you can see here, it's a bigger number. And if we have the decimals, we know exactly where to put the decimals, and this will equals to 100 as well. So that's what we are pulling out here. And then we store it into the token amount variable and the token decimals variable. The next thing that we are going to do is create that instruction to close the account, and for that we use the function getCloseAccount instruction, and here we provide the account, which is the token account to close, the one that we provided here on top. Remember, the token account that was created for our Raydium token. The destination, this is where we will put the sol that is in that token account back. So we're going to send it back to our primary wallet, so our wallet that we created here on top, which is the primary wallet, and also the owner from that associated token account. And that's why we also specify here the owner, and that is our wallet. Next, we are going to create a burn instruction, because if we want to close this token account, we cannot do that if there are still tokens within that token account. And I can show you that real quick, because here we create that transaction just as what we did before, but we're going to remove this burn instruction. So we're only going to try to close this token account. So if we now go back to our terminal and we run npm run 5 close like this, you will see that we get an error, and the error here says non-native account can only be closed if the balance is 0, and that just means that we are trying to close a token account that has still tokens in it, and that's why we are going to burn them first. And for that we have a burn instruction, and we can use the get burn checked instruction for that, where we specify the token account to close, the address, which is our mint, the Raydium mint, the authority, our wallet, the address, and that is the wallet, the primary wallet, once again, that we imported here on top. And then we also have the amount and the decimals, and that's why we set these here earlier. So we exactly know how much tokens we need to burn so that this account is actually empty. So if we take this instruction now and we put it back into our transaction, just like this, you'll see now we have two instructions, the burn instruction and the close account instruction. And this is just the same as what we did before. We're creating that transaction message, we are going to sign it, we expand the type, and then we're also going to send and confirm it. And if we now run once again this comment, you will see that we now closed the token and reclaimed the sol. So if we go back to our Explorer, I believe here, this is the token account. If we refresh this now, you will see that this, of course, still shows the address, but it says account does not exist, and we have no real information here any longer. We can also have a look at Surfpool Studio, so the last transaction, that's exactly what we did here. So we have that burn instruction, and you can see here our primary wallet. We are deducting, of course, some fee to run this instruction. And then we also update the actual token account. As you can see here, we are going from 100 tokens to 0, and you see it nicely updates here. And that's why Surfpool is so great, because we can see the differences between the first state and the second state. So we see that we no longer have these tokens in here. And also here you can see that there is a change in supply for our Raydium token here. And then the second instruction is where we actually close that token account. And as you can see here, it says delete account, and this was our associated token account that now has been closed. But more important, you see that our primary wallet got some extra sol. So it went from 999,000 to more than 10,000 sol. So that's what we get back, that sol that we airdropped into that wallet, but also the fee is now returned to our primary wallet. And that is because we closed that token account, and the rent from that token account has been returned to our primary wallet. Of course, we airdropped more sol into that account, and as it is part of the account balance, it was also returned to our primary wallet. Alright, so that's it for this video. We now covered Solana accounts and we also completed our daily tasks. I hope you now understand accounts a bit better and how you can reclaim the fee from these associated token accounts and maybe get back some SOL that is just out there as rent for all these open associated token accounts for the tokens that you traded in the past. Now in the next video we are going to look at the Solana programs, so make sure to subscribe so you don't miss any of the upcoming videos. And with that said, I hope you think it was interesting and I'll see you in the next one.